Would you like to go through it together? Let's do that. All right, so what is your original quadratic equation?
-4 minus 5.
Okay. What do we do first?
Have to move the 5 over this.
So how many ends will we have? Good job. So at this point, we're going to hop in and do our thing, right? So for A, you used 25. For B, you used -20. And for C, you used 4. Okay. So your quadratic, your first step is the one where you do just a little bit of math, really. Maybe you do your B squared and you do your 2A. So we're going to have N equals the opposite of B, which is no. Don't look at this anymore. That problem does not exist anymore. We're looking only at our red numbers, A, B, and C. Did you write those down? Okay, that's important. So we start the quadratic formula with the opposite of B, which would be what? Correct. Plus or minus, and then you draw a big long square root sign like that. And what's the first thing that we put into our square root sign? You do not. So got to know your formula well. Gosh, if only there were a song to help us remember the formula. Geez, what goes the first inside the square root sign? You guys should all somewhere on your paper have the quadratic formula written down so that you're looking at it. If you don't have it, let me give it to you one more time. I won't make you sit and listen to me sing it again, but it is right here, and it should be right at the top of whatever paper you have on your desk. So it's one thing to not know what the formula is, right? It's another thing to say I'm having trouble, but to not know what it is, that's going to be a real deal breaker for us. So what goes first inside the square root? The -20, right? And so if you square that, it becomes a positive. So what is 20 squared? So I'm going to put 400 right here. Got that? That's always B squared, dude. And then I'm going to put -4, and then I'm going to put 2 multiplication parentheses, and I'm going to leave them blank for about 20 seconds. And then on the bottom, I'm going to do 2 times A. What's that? Okay, now we're going to go back and we're going to fill in these 2 blanks. What goes in the first one? Right. And what goes in the second one? Good. So we talked yesterday about, if you guys are all interested as a group, I know this is not your math problem because you all get different ones, woohoo, but this is Alana's. And so that cool thing that happened by the last example of the lecture yesterday, your brain was probably pretty well fried. But Alana's getting one of these that's really weird. So if you want, because chances are, you could get one of these too. So Alana and I have worked through, we got it all set up. We found our A, our B, our C. We put it in and we did the first step. Now, Alana, is this minus going to stay as a minus or is it going to switch to a plus? I agree. So what we have to do now is we just have to take these 3 numbers in this green cloud and multiply them together. And what do those equal? Yeah, but quit thinking of you got to stop with the negative, okay? Just ignore the negative. That you did this yesterday too. Once we know the minus is going to stay, notice where I put my green cloud. Heck with the negative. Okay, just the numbers. We already know it's going to be a minus, so forget it. What's 4 times 25? 100. And what's 100 times 4? Yes, because these 2 in this purple box equal 100, right? So if I replace that with 100, and then I still have to multiply it by 4, 100 times 4 is 400. So what I really have inside the square root sign is 400 minus 400. And what does that equal? Good. And this happened to us in the very last example yesterday in our notes. When you get the square root of 0, that just equals 0. And putting a plus or a minus in front of a 0, like we're about to do, serves absolutely no purpose. So this is the kind of problem where you actually only get one unique answer. So in your case, you get n equals 20 over 50. All this other stuff, I'm going to use the biggest, fattest, red, most obnoxious pen I have. Look at this. All this stuff goes away because if what's after it equals 0, it serves no purpose. So your only answer is this, but you have to, of course, reduce it. Divide them both by 10. What do you get? So your answer is n equals just 2/5. Whenever you get 0 in the square root, those are the ones where it looks like you just got one answer. You actually got two answers. They both happen to be the same number, 2/5. Okay? Anyone else want an assist? You want to read me your problem? 3p?
Yeah, the second. Oh, minus 13p plus 4p. -4.
That's interesting that you actually have two like terms on the same side of the equal sign. That's pretty neat. I didn't see that one coming, but okay, I like it. So the 3p squared is just going to stay there. He doesn't have anyone to go with. Combine these two. How many p's do you get?
-90.
Mm-hmm. So what else do we have to do before we can start? Plus 4. Good job. So now we have it set up and we're ready to actually do the formula. At this point, don't look at the original problem anymore, right? We're not interested in that one. So our A value is 3. What's our B? What's our C? Nice job. So here we go. P equals what? What goes first? No. Quadratic formula starts with negative B, aka the opposite of B. So I'll ask you again. Yes, the opposite of the B is the opposite of -9, which is +9. So we're going to put 9 plus or minus a big long square root sign. What goes first inside the big long square root sign? Nope. I can pull this down, but I know it's on your paper already. So I don't know why I keep doing this. You should just look down at your paper. What goes first? I already have that, dude. Let me circle it and give you a hint right there. B squared goes next. B is -9. What's -9 if you square it? No, it will never be a negative. It will always be a positive. This number, if you look back at your notes, you'll remember that this number right here is going to be positive 100% of the time. Are we clear? That will never be a negative number. It always turns to positive if it's negative because you're squaring it, okay? Then the next thing I do is I copy down the -4ac, and I just leave the a and the c blank, and then I put it all over 2 times a, which in this case is what? 2 times a, which is what? Now we're going to go backfill these two parentheses. What goes in there? So, good. So I'll ask you the question I ask every single time. I will never fail to ask this question because this is the question that will determine how we go from here. This minus with the green arrow pointing at it, does it stay as a minus or switch to a plus? Yes, it does. And so like I told Alana a minute ago, don't think about negatives anymore. You already know in the parentheses that it's going to be a number minus a number. No more worry about negatives. So all you got to do is just worry about the numbers multiplied together. And I drew this green cloud very carefully to not include that minus sign. We're done talking about it. What is 4 times 3? What's 12 times 4? I agree. So really what's happening inside your square root is 81 minus what you just said, 48. Are you with me? Now we have to do some subtraction, right? Sometimes that'll be addition if it changes, but this one is just subtraction. What's 81 minus 48? I agree. So at this point, this is where you make a choice as to how much more work do I have to do. And it's all determined by the square root. And if I look at the square root of 33, my question becomes, how can I, making one of those cute little tree things, how can I break down the square root of 33 using a tree? What numbers can you think of that multiply to make 33? Jesse's trying to give you the answer, I think, there. Did you hear him? Was that were you hooking her up? Yeah, I just really I want Addie to tell me, okay. It's important in these conversations that the right student is having the conversation. Otherwise, I get false readings and I think dumb things. So what numbers multiply to make 33?
11 and 3.
Okay, what else? Because 11 and 3 don't help me because they're not on the red list. So what else can you think of?
1 and 32.
And that, of course, is illegal to use the number times 1. So what can you tell me about the square root of 33? I agree. And this is actually the best news in the world because it means if you get to that square root part and it cannot be broken down, then it means that that is your final answer and you are done. Mark my words, those will become your favorite because if you can't break them down, you don't have any more work to do. So now you got to type that in just like I showed you about 10 minutes ago. Got it? I'll be right with you, Jesse. Did you have a hand? The fact that you're using 13 and 52, so that tells me you're breaking down like 600 and something. So if you go to your calculator and you type in the square root of 676 and hit enter, something needs, do you? Okay, so we have to break it down so you know it's not a square rootable number. Okay, so what we want to do is probably, because see the trouble with 52 is it's treeable. So what we want to do is take the little baby trash approach. So you should be taking 676, dividing it by 2, 676, dividing it by 3, 676, you would not, it divides by 2. Does it divide by 3? It does, doesn't it? Divide it by 6. When you divided it by 2, you got 338. Is that correct? Okay, and that's not useful. Dividing it by 3 gives you 200 and it does. Okay, so and then 6, well, yeah, 6 has to be a decimal of 3 fails. And then we just keep going on down the line. Maybe try 676 divided by, don't try, well, you could try 7 to 7. Oh, you have? Okay, so the fact that you found 13 and 52, I guess let's go down that route. So here's another approach. You can take and focus on big numbers like this, call for maybe a different approach. You could try 676 and just try dividing it by numbers on the red list, like 4, 9, 16. You wouldn't do 25, duh, but you could try 36. You could try 49. Try that more direct approach. Did any of those work? Okay, then let's. So you divided 676 by 4. And what'd you get? Okay. What is happening right now? I'm sorry, I just need a second. I don't know what's going on over here, but okay, try this again. Because I thought that we had a conversation and then I don't know what you guys did. I need you guys to put the square root of 676 into your calculator. Yeah, I just did it too. And I thought it was 26, but you guys were yanking my chain over there. Do you guys know how to do the square root on your calculator? It just literally equals 26.
Oh my.
You're welcome. Because you read the problem to me incorrectly. Yes, you said there's a 4p right there.
Oh.
I thought that was odd. I even called you on it and said, wow, there's like terms on the left side. And you were like, yeah. So you just gave me the wrong problem. So we said to start over.
Oh.
It's not 4p, dude. It's a 4.
I was.
Oh, I mean, come on. This job's hard enough. You can't be doing stuff like that. So you gotta start over. That's a 4. So we're going back to the drawing board. Jess, you need some help, buddy? And does it equal 0? It gave it to you just like that. That's nice of them. Good. So I'm going to assume that you wrote down your A value, your B value, and your C value. Okay, so what does the quadratic formula start as? A equals, not X equals, A equals. Yeah. And what goes in those blanks? Good. So I'll ask you the question again, 100% of the time. Is that a minus that will stay a minus or switch to a plus? I agree. So from this point on, for the next 20 seconds in our conversation, we will not utter the word negative. Are we clear? Because you and I both already know that the minus and that thing are going to go away, right? So as far as you're concerned, inside the square root is 64 plus 192. You got that? You sure? Okay, so now when we add those two numbers together, it looks to me like we're going to get 256. Is that correct? So the first thing you want to check is 256 just on its own a square rootable number? Is it on our red list? Can I square root it? Oh, well, this is interesting then. So what that means is we're going to get one of these problems where since there's no square root, it's just -8 plus or minus 16 over 32. Hey, I'm going to have you all stop for a second, and I'm recording too, so rad. You should hear this. I get that you're busy, but you should hear this. I generally don't do this, but I did it later in the day, and I kind of thought, I kind of like this. I didn't say this, but you can Dorito. This is, by the way, is Jesse's problem, and we've gotten to right here. You'll remember this is one of the ones that's going to have, this is a pathway problem. Hope you're listening. Before you pathway, you can actually do the Dorito. And I'd never know if that's attractive to people or not, because in my world, I don't do it because I don't care about numbers and their size and stuff. But I think that for a lot of us, if we Dorito these down and then pathway, you might find the addition to be more friendly. So if I take every one of these three numbers that's free and out in the open now, there's my funky little Dorito. What can all three of those numbers be divided by? If you take these numbers and you actually divide them early, you can make the pathways a lot smaller and more manageable. So you said it, but I was getting ready to pause my recording. What can these all be divided by? Let's divide them all by 8. So what happens now is the -8 becomes -1. The plus or minus stays. What's 16 divided by 8? And what's 32 divided by 8? Personally, I view that step as a waste of time for the reason that I just said. I don't care about big numbers, but you might find this more palatable now because the pathways are a little simpler. So let's take the yellow pathway first. What is -1 plus 2? 1. So one of Jesse's answers is A equals 1 over 4. What's nice about the early Dorito is you don't have to reduce later, I guess. The other pathway is the purple pathway. What's -1 minus 2? -3. So Jesse's other answer is -3/4. Everybody got that? The moral of that 2-minute take up of your time is that you can Dorito before you pathway on problems like this. Are we clear? Righto, Jess, that help? Oops. But now if you do the early Dorito reduce, then maybe that'll help you in the future. I don't know. Did you guys get yours figured out over there? You're good? More questions?
Good question.
Yeah, yeah.
You have, I was just gonna ask, do you have any more sheets that have like over
There's probably some over on the counter over there behind Mr. Roscoe. Just read it to me right off the screen, okay?
Or these?
Okay, so what do we do first? We can't do that yet.
Oh, we have to.
Yep, we need the right side. It's usually going to be the right side, honestly, with where we're at right now. So we want one side to equal 0. The best way to do that is add the 1 across. So what do we get for real? And now we're ready to have the conversation. And I'm just going to usher that right off the screen because it's dead to me, right? It doesn't help us. So what's A? B? C? Good. It might seem like a waste to write them down, but my experience tells me that just pulling them out helps. So you ready? All right, let's do this. So Z equals, what do we do first? So negative 11 leads the way. Good job. Keep going. Nice job. Now I'm gonna do -4 blank blank. Okay, I don't really think much. My pencil just kind of does its own thing there. And then I put all over what? 2 times A, which is just 2 times A. 2A just means 2 times. Yeah. Yep. So it's an 8. Now what I do, now that the break is over, is I go back and I refill A and C, the 2 parenthesis sets. So what am I going to put in those blanks? You have any questions so far? This is a lot of what I saw you doing is look at the formula, do a little work. Look at, and that's how you're going to be for the first 7 or 8 problems. You have to keep looking, and that's normal, okay? So just follow the formula. Now we have to answer the one critical question, and that is pertains to that sign. Is that going to stay as subtraction or switch to addition? I agree. So what you have to do next is take these numbers in this green cloudy box thing and multiply them together. And don't say negative because here's what happens when you do stuff like this. And I do not mean to micromanage, but if you say -64, then eventually you might do something stupid, like think that minus that I'm pointing at and that negative that you just said, you're like, oh, it's a minus and a negative. They're going to switch to plus. And you and I already established that it is not changing. So if you just multiply the 3 numbers in the green box, it is 64. All right. And again, not to micromanage, but I don't want your brain to ever convince you that now there's a new negative to go with the minus. This is straight up 121 minus 64. End of conversation there, right? Now you got to do the math. What is 121 minus 64? Now, if you had $121 in your wallet and you dropped 64 bucks on a new pair of pants or something, you don't have 100 left, right? You only have 121 and you just dropped 64 bones. I agree with that. I like that answer a lot better. So I'm going to put the answer to that in this little square root sign. And this is like the final crossroads where there's like 3 branches of this road now that we can take. The most attractive one is the one that you got because of this. How do you break down the square root of 57? You can't. It's dead. Its only way to multiply it is 3 times 19. And that's useless, right? So these are our favorite problems because we are done.
Thank you.
You're welcome. What is your original problem? Oh gosh, I keep doing that these days. Okay. Minus 60R, 16R, and what was the rest? Okay. So we should be working with 15R squared minus 16R minus 15. Okay. So our A value is 15, our B value is negative 16, and our C value is negative 15. So I'm going to hum through this real quick. You should have R equals 16. Yeah, sure. That's fine. Yeah. Oh, hold on a second. Gotta pause this. So we have 16 plus or minus a big long square root sign. And inside of there, we're going to do 16 squared, which is what, 256. And then we're going to have minus 4 blank blank. And then that's all over 30. And in your blanks, you're going to put a 15 and a negative 15. So you're going to wind up with 256 plus 600 plus 300, 900. So you're going to wind up with 16 plus or minus the square root of 1,156 all over 30. Because I did this problem right here. If you just said, I heard you say 30, and that was where I went, uh-oh, here we go. This is no good. You forgot about the 256. Yeah, that's just wrong. Like you can't do that. The inside the square root, you don't get to just do the 4AC and put that as, I mean, you're completely ignoring the b squared. So if you add them together, you get 1156. And I don't think 1156 is square rootable, but let's find out. I don't know that one. But yeah, it is. I'll be darned. I learned something. So the square root of 1156 is actually 34. So you should have 16 plus or minus regular old 34 divided by 30. And you can choose at this point in time, do you want a Dorito then pathway it or pathway then reduce? I couldn't care less. You pick. You want to reduce all the numbers right now? That's fine. So that was what I was showing you about 10 or 15 minutes ago, is you can take all 3 of these numbers and divide them all by the same amount right now. The best you're going to do here is 2. So there's really not a lot going on here, but it does wind up becoming 8 plus or minus 17 all over 15. Are you okay? I can kind of tell when you're a little sketchy, just body language. Are you sure you're 100%? Okay. So now it's time to do the different pathways. And so one of the answers is going to be arrived at by taking the upper pathway plus. What's 8 plus 17? And so you put 25 over 15, and then you reduce those both by 5, and you get 5/3. So one of your answers is R equals 5/3. Like, done, right? Now we reset and we go trace the lower pathway, the low road. What is 8 minus 17? So one of your other answers, or your other answer, is -9 over 15. So we look at that as we always have, just as, I mean, you got to kind of respect it on multiple fronts. Number one, overall, is it going to be positive or negative? Like, is this a positive or a negative answer? Because it's negative, because it's a negative being divided by a positive. So for our other answer, we know that it's negative. Let's get that negative out of there. And what can 9/15 be reduced by? So what do we get? So the lesson I think for you that needs to be learned in that problem is the important, and this happens all the time, is people get so wrapped up in this 4AC part and they're like, oh, I got it. But then I've seen it hundreds of times where people then just completely ignore that. It's like, you can't do that. He's there. It's just, we could just agree though that however you did that, just don't do that again. Like, it's okay, go off to the side, I don't care. But then the 256 cannot just be pushed aside. Like, he's there. It's either going to be 256 minus the answer to the green stuff or 256 plus the answer to the green stuff. But the 256 isn't going anywhere. Got it? Okay. You guys have some other mathy questions? Oh boy, these crazy. I wish they'd just use X's. Wouldn't that be nice? Just plus 7. Q minus 3. And does it equal 0? Oh, how nice. It equals Q. Oh, I don't know. Is this what it says right on your screen? Exactly this. Okay, then you need to be working with 5Q squared plus 6Q. Yeah, you've got to make it equal 0. 100,000,000%. 1 equals 0. Yeah, so that's going to change your B value and change everything.